Good afternoon, everyone. Can you hear me? Can you hear me? Okay. So let us continue the problems of exercise 10.3. Show that modulus of vector A into vector B plus modulus of vector B into vector A modulus of vector B into vector A is perpendicular to modulus of vector A into vector B minus modulus of vector B into vector A for any two non-zero vectors A and B. For any two non-zero vectors A and B. Show that modulus of vector A into vector B plus modulus of vector B into vector A is perpendicular to modulus of vector A into vector B minus modulus of vector B into vector A, for where A and B are two non-zero vectors. How can you prove that two vectors are perpendicular? Dot product is equal to 0. Okay, let us consider the dot product here. Modulus of vector A into vector B plus modulus of vector B into vector A dot modulus of vector A into vector B minus modulus of vector B into vector A. Find out this dot product. This is equal to, here modulus of A is a real number. So multiplying with this, you will get this as modulus of A square into vector B dot vector B, multiplying these two terms, then minus these two terms, modulus of vector A and modulus of vector B are two real numbers, then B bar dot A bar. Now these two terms here plus modulus of vector B and modulus of vector A are real numbers, then vector A dot vector B Next term is multiplying these last two. Here modulus of vector b the whole square into a dot a. So this is equal to vector b dot vector b. It is modulus of vector b square. So modulus of vector a square into modulus of vector b square. Here b bar dot a bar is the same as a bar dot b bar. One is negative and one is positive. So these two terms get cancelled. Then minus, here again modulus of vector b square into a dot a is modulus of vector a square. Both the terms are same as modulus a and modulus b are real numbers. So this is equal to 0. Since the dot product is equal to 0, we can say that the given vectors are perpendicular. Can conclude the answer. Since the dot product is equal to 0, the given two vectors are perpendicular to each other. Is it clear? Okay, let us move to the next one. If A, B and C are unit vectors, such that A plus B plus C is equal to 0, find the value of A dot B plus B dot C plus C dot A. If A, B and C are unit vectors such that A plus B plus C equal to 0, find the value of A dot B plus B dot C plus C dot A. See, in this it is given that A, B and C are unit vectors. So what can you say about modulus of vector A, modulus of vector B and modulus of vector C? A, B and C are unit vectors. So, unit vectors means the magnitude is equal to 1. So, modulus of A is equal to 1, modulus of B is equal to 1 and modulus of C is equal to 1. And also it is given that vector A plus B plus C is equal to 0. The sum of these three vectors is equal to vector A plus vector B plus vector C is equal to 0. It is a 0 vector. So we had learned that if any one of the vectors is a zero vector, then the dot product C A plus B plus C dot A plus B plus C will be equal to, what about this dot product? Given that A plus B plus C is equal to 0. So what about the dot product A plus B plus C dot A plus B plus C? Okay, this will also be equal to 0. Now let us multiply the terms here. Vector A dot vector A, it is modulus of vector A square. Then A dot B plus vector A dot B plus these two A dot C plus multiplying with the second vector B dot vector A plus B dot vector B is modulus of vector B square, then plus B dot C plus the third vector is C dot A plus C dot B plus C dot C gives modulus of vector C square. This is equal to 0. Now you know that modulus of vector A is 1, so its square is also equal to 1. Here modulus of vector B is 1, square is equal to 1. Here modulus of vector C is equal to 1, so its square is equal to 1. So 1 plus 1 plus 1, which is equal to 3. And A dot B and B dot A are same, so we can write it as 2 vector A dot B. Similarly, A dot C and C dot A are same, so we can write it as 2 vector A dot C or C dot A. So it is A dot C, then plus third one is B dot C and C dot B. We can write this as 2 vector B dot C. This is equal to this 1 plus 1 plus 1 transposed to the right side, it becomes minus 3. Now 2 is a common factor here. Transposing it to right side, we will get this as A dot B plus A dot C plus B dot C is equal to minus 3 by 2. This is the value of the required sum, A dot B plus B dot C plus C dot A. Okay, now moving to the next one. If the vertices A, B and C of a triangle ABC are 1, 2, 3, minus 1, 0, 0, 0, 1, 2. Respectively, then find angle ABC. if the vertices A, B and C of a triangle ABC are 1, 2, 3, minus 1, 0, 0, 0, 1, 2 respectively, then find the angle ABC. See, if you have to find the angle ABC, this is the angle B, angle ABC. So this angle is formed by the vectors BA and BC. Always remember this, we are considering vectors here. So you have to consider it as B is the angle formed by the vectors BA and BC. So first you have to write B vector BA and then BC. The vertices are given here. So you have to write BA. Here the vertices of A and B are given. To find BA, this is to be taken as x2, y2, z2 and this is to be taken as x1, y1, z1. x1, y1, z1 and x2, y2, z2. So, to write vector BA, x2 minus x1i, x2 minus x1i. This is to be taken as x2, y2 and z2. This is to be taken as x1, y1, z1. So it is x2 minus x1, 1 minus minus 1 which is 1 plus 1i, then plus 2 minus 0j plus 3 minus 0k, which is equal to 2i plus 2j plus 3k. Similarly, you have to find BC. Write the vector BC. To write vector BC, you have to consider this as x2, y2, z2 and this one as x1, y1, z1. BC. Zero minus minus 1. So it is 1i, then plus 1j, then plus 2k. Now we had learned that to find the angle between two vectors, theta is equal to cos inverse BA dot BC divided by modulus of vector BA into modulus of vector BC. Find out the value of this dot product BA into BC, BA dot BC and give your answer. Two vectors are here, 2i plus 2j plus 3k, 1i plus 1j plus 2k. To find the dot product when the vectors are given in component form, a1, a2 plus b1, b2 plus c1, c2. What about the dot product? BA vector BA dot vector BC is 2 into 1 plus 2 into 1 plus 3 into 2. So the dot product is 10 by, what about the modulus of vector BA? Modulus of vector BA, so it is root of 17 into, what about this modulus of vector BC? To find this modulus of vector BA, it is root of 2 square plus 2 square plus 3 square. To find modulus of BA, we have to take the root of 2 square plus 2 square plus 3 square. Similarly, find the modulus of vector BC. It is equal to root 6. This is equal to cos inverse 10 divided by root of 102. This is the angle between BA and BC, which is angle ABC. So angle ABC is equal to cos inverse 10 by root of 102. Okay, let us move to the next one. Is this clear? Okay, always remember this. And if you have to find angle B, then you have to consider the vectors BA and BC. Now the next is show that the points A127, B263 and C310 minus 1. 310 minus 1 are collinear. Show that the points A, B and C are collinear. What are collinear points? collinear points. Points lying on the same line. That is, we have to show that A, B and C lie on the same line. To show that, let us consider vector A. First, let us find this vector AB, then vector BC and vector AC. Let us find these three vectors. Find out these three vectors. Points, vertices are given to us. A and B are given. So, to find vector AB, x2 minus x1i plus y2 minus y1j plus z2 minus z1k. So, you will get AB as 2 minus 1 is 1i, then 6 minus 2 it is 4j, then plus 3 minus 7 minus 4k. Okay, 2 minus 1, it is 1i, 6 minus 2, it is 4, 3 minus 7, minus 4. Similarly, find BC and AC. To find vector BC, 3 minus 2 it is 1, 10 minus 6 4, minus 1 minus 3 it is minus 4. So minus 4k. Now to find AC, 3 minus 1 it is 2i, then 10 minus 2, 8j, minus 1 minus 7 it is minus 8k. Now we have to find the modulus of each of this. Vector AB. What about the modulus? Modulus of vector AB. It is root 33. So here same will be the modulus of this vector BC. That also will be equal to root 33. What about this modulus of AC? It is root of 132, which can be written as 4 into 33. Root of 4 is 2 root 33. 132 can be written as 4 into 33. Then root of 4 is 2. See, from this we can observe that the magnitude of vector AB is root 33, that of BC is root 33 and AC is equal to 2 root 33. And also modulus of vector AB plus modulus of vector BC is equal to modulus of vector AC. This is root 33 plus root 33, which is equal to 2 root 33. AB plus BC gives AC. And also B is a common point here. So AB plus BC is equal to AC. That shows that A, B and C are collinear. A, B and C are collinear points. How can we show that if three vertices of a triangle are given like this, how can we show that the triangle is a right triangle? If the question is show that the triangle formed by these three vertex points forms a right triangle, how can we show that? Okay, by applying Pythagoras theorem, that is similar way you have to find AB, BC and AC, and then you have to find AB square plus BC square is equal to AC square, or the square of any one of the sides is equal to sum of squares of the other two sides. Okay, so in your textbook, question number 17 is such a question, do it as homework. Okay, moving on to the next one, next topic. Vector product or cross product. Vector product or cross product. We were discussing about scalar product or dot product and their applications, and here vector product or cross product. So let us write the definition. The vector product of two non-zero vectors vector A and vector B, vector A and vector B is denoted by A cross B. It is denoted like this, and we read this as A cross B. And defined as A cross B is equal to modulus of vector A into modulus of vector B sin theta n cap. Sin theta into n cap. A cross B is defined as modulus of vector A into modulus of vector B sin theta into n cap, where theta is the angle between A and B, angle between vector A and vector B, and also n cap is a vector which is perpendicular to both A and B. N cap is a vector which is perpendicular to both A and B. See the definition. Two non-zero vectors A and B. For this vector, we can define the vector product or cross product denoted by A cross B, such that A cross B is equal to modulus of vector A into modulus of vector B sin theta into n cap, where theta is the angle between A and B and n cap is a vector which is perpendicular to both A and B. So here the definition of cross product is modulus A into modulus B sin theta n cap. The dot product of two vectors is defined as A dot B is equal to modulus A modulus B cos theta. And the cross product is defined as A cross B is equal to modulus A modulus B sin theta n cap. From this definition itself, we can say that this is a vector as n cap is here. Okay, this is a vector. A cross B is a vector. So we can write some results. A cross B is a vector, whereas A dot B is a scalar. Okay, A cross B is a vector which is perpendicular to A and B. This is a vector in the direction of n cap, where n cap is a vector perpendicular to A and B. See here you have to make a change. N cap is a unit vector. N cap is a unit vector which is perpendicular to both A and B. So the first result is A cross B is a vector. What happens if any one of these two vectors is a zero vector? Either A or B is a zero vector. What happens to this cross product? See this definition. A cross B is defined as modulus of vector A into modulus of vector B into sin theta into n cap. What happens if any one of these vectors is a zero vector? A cross B will also be a zero vector. Okay. If, so you can write this, if either A or vector B is a zero vector, then A cross B is also equal to a zero vector. A same result is there for dot product also. If either A or B is a zero vector, then A dot B is also equal to 0. If A and B are two non-zero vectors, then A cross B is equal to 0 if and only if. Can I complete this statement? A similar result we had learnt in dot product also. If A and B are two non-zero vectors, then A dot B is equal to 0 if and only if A is perpendicular to B. In case of dot product, in that case A, B cos theta, A and B are not equal to 0, so cos theta is equal to 0. Cos theta is equal to 0 when theta is equal to pi by 2. So we can say that A and B are perpendicular. What about the cross product is equal to 0? A cross B. So here A cross B is equal to 0 if and only if vector A is parallel to vector B. If the dot product is equal to 0, we can say that the two vectors are perpendicular. If the cross product is equal to 0, then we can say that the two vectors are parallel. If A cross B is equal to 0, if and only if vector A is parallel to vector B. So we can write vector A cross vector A is equal to 0. These two are same vectors, A and A. that means they are collinear vectors or parallel vectors. Therefore the dot cross product is equal to 0, or A cross minus A will also be equal to 0. As here the angle is 0, theta is equal to 0, here the angle is pi. See, if this is vector A, the same vector A here, A cross A means the angle is 0, so sin 0 becomes 0, so A cross A is equal to 0. If we are considering this case, this is vector A minus A in opposite direction. Minus vector A is in opposite direction. That means the angle formed here is pi. So sin pi will also be equal to 0. Sin pi, the value of sin pi is 0. So the cross product A cross minus A is equal to 0. Now as the fourth result, what happens if theta is equal to pi by 2? When theta is equal to pi by 2, we can write A cross B is equal to modulus of A into modulus of B. Okay, now the next one. What can you say about this I cross I? What about this I cross I? We can use this result. A cross A is equal to 0. So I cross I will be equal to 0. J cross J is also equal to 0. K cross K will also be equal to 0. Can you say what will be this I cross J? I cross J is equal to, this is equal to K, as this cross product is defined as a vector which is perpendicular to both the vectors. Okay, I, J and K are mutually perpendicular unit vectors. So here K is a vector, K cap is a vector which is perpendicular to both I and J, and also you have to take this in anti-clockwise direction, that is I to j, then j to k, k to I. The cyclic relation you have to consider, I cross j gives k, j cross k gives I, then k cross I is equal to j. See, I cross j is equal to k cap. Now j cross k is equal to I, and k cross I is equal to j. Is it clear? If this is in the reverse order, that is j cross I is equal to I cross j is equal to k cap, j cross I is equal to minus k cap, then k cross j is equal to minus I cap, and then I cross k is equal to minus j cap. So we can write here A cross B is equal to minus B cross A. In case of dot product is commutative, but here it is not commutative as A cross B is equal to minus B cross A. Since it is a vector, it has a direction. So when we are considering A cross B, we are taking n cap, and when we have to consider B cross A, the vector which is in the opposite direction of n cap, that is to be taken as minus n cap. So A cross B is equal to minus B cross A. Now the next result is, if A and B represent the adjacent sides of a triangle, A and B represent the adjacent sides of a triangle, its area is given by half modulus A cross B. Its area is given by half modulus A cross B. If A and B represent the adjacent sides of a triangle, then its area is equal to half of modulus of A cross B. Similarly, we can write another result if A and B are the adjacent sides of a parallelogram. So the next one is, if A and B represent the adjacent sides of a parallelogram its area is equal to modulus of A cross B. So if A and B are the adjacent sides of a triangle, its area is given by half modulus A cross B. And if A and B are the adjacent sides of a parallelogram, then its area is given by modulus of A cross B. Now the next one is the distributive property. A cross B plus C is equal to A cross B plus A cross C. A cross B plus C is equal to A cross B plus A cross C. Similarly, lambda into A cross B equals lambda A cross B, or this is equal to A cross lambda vector B, where lambda is a scalar. And now, when the vectors A and B are given in component form, if vector A is equal to A1i plus A2j plus A3k and vector B is equal to B1i plus B2j plus B3k, this is the component form of vector A and B, then you know that how to find the dot product. A dot B is equal to A1 B1 plus A2 B2 plus A3 B3. It is the dot product. Here the cross product is defined as determinant. This is not modulus. It is determinant I, J, K, I, J and K. Since A cross B is a vector, we have to get the result as a vector. So the first row is to be taken as I, J, K. Then A1, A2, A3, the scalar components of vector A. Then the scalar components of vector B. The value of this determinant will give A cross B. You know how to find the value of this determinant. I into A2 B3 minus B2 A3 minus J into A1 B3 minus B1 A3 plus K into A1 B2 minus B1 A2. Isn't it? When you expand using the first row, you will get the cross product A cross B. So the results once again, if A and B are two vectors, then A cross B is also a vector. If either A or B is a zero vector, then the cross product will also be a zero vector. If A and B are non-zero vectors, then A cross B equal to 0 implies A is parallel to B. From that result, we can say that A cross A is equal to 0 and A cross minus A is equal to 0. Then using that, we can come to this. If theta is equal to pi by 2, A cross B is equal to modulus of A into modulus of B. then I cross I, j cross j, k cross k, all these are equal to 0 vector. Then this is to be taken in cyclic order. See, I cross j is equal to k, j cross k is equal to I, k cross I is equal to j. And this here taken in anti-clockwise direction. If you are considering in clockwise direction, I cross k is equal to minus j, k cross j is equal to minus I, and j cross I is equal to minus k. Then vector product is, or cross product is not commutative. Then to find the area of a triangle, half of modulus a cross b, if a and b are the adjacent sides. Similarly, to find the area of a parallelogram, if a and b are the adjacent sides, it is equal to modulus of a cross b. Then the distributive property here. And when a and b are given in component form, the cross product is given as determinant ijk, a1, a2, a3, b1, b2, b3. That is the scalar components of vector a and the scalar components of vector b. So let us do some questions. Exercise 10.4. First one, find modulus of a cross b if a is equal to I minus 7j plus 7k, I minus 7j plus 7k, and b equals 3i minus 2j plus 2k, 3i minus 2j plus 2k. So first we have to find a cross b. To find out this, determinant I, j, k, the scalar components of vector a, 1 minus 7, 7, 1 minus 7, 7. Then vector b, the scalar components are 3 minus 2, 2. So you can find the value of this determinant. I into this into minus 7 into 2, it is minus 14, minus 2 into 7, it is plus 14. I into minus 14 minus 14, which is equal to minus 14 plus 14, minus j into 1 into 2, it is 2, minus 3 into 7, it is 21, then plus k into 1 into minus 2, it is minus 2, minus 3 into minus 7, it is minus 21. So it becomes plus 21 here. So this is equal to 0i minus 2 minus 21 minus 19. So it becomes plus 19j then plus 19k. Now find the modulus. modulus of A cross B is equal to root of, this is a vector. So to find the modulus, it is 0 square plus 19 square plus 19 square. See, this 19 square is common here. So we can take it outside the square root. It becomes 19. Then root of 0 square is 0 itself. Here 19 square is taken as a common factor. So 1 plus 1 it is 2. So it is 19 root 2. Is this clear? So is there any doubt in this vector product or cross product? Okay, then we will do this remaining questions of exercise 10.4 in the next class. Thank you.